Hey there, welcome to this explainer. Grab a seat. I'm your host, and today we're sitting down for a one-on-one whiteboard session. As a senior IT architect, a big part of my job is mentoring junior colleagues like you, really making sure you truly understand the core foundations of the systems we build every day. So today we're going to unpack the massive paradigm shift from physical bare metal servers to the absolute magic of virtualization. And trust me, this isn't just a history lesson. It is literally the bedrock of modern cloud computing. You think spinning up a server in 10 seconds is normal? Well, let me tell you about the 6-month wait. I know it sounds like a joke, but I promise you it's absolutely not. Before, you could just casually click a button to launch a test environment. Us senior architects used to battle the heavy, slow chains of bare metal servers. You kind of have to understand that the speed you're used to today is a total modern luxury. It took a massive evolution to get here, and really understanding that past pain is key to understanding how we engineer today's networks. All right, let's set the stage with Section 1, the bare metal bottleneck. So the crucial point here is just how painful scaling used to be. Back in the day, if our applications started getting popular and we desperately needed more computing power, we couldn't just scale up instantly. No way. Instead of that near-instant agility, we faced massive lead times. We had to go through this rigorous physical procurement cycle. You'd wait weeks or even months for delivery, physically unbox the hardware, rack it in a freezing data center, cable it up, install the operating system, and configure the whole shebang. Getting just a single bare metal computing device online was an incredibly slow, expensive, and rigid process. And here is the real kicker: 20%. What's actually mind-blowing about this is that after waiting all those months, our massive, super expensive physical servers were vastly underutilized. Often they were running at just 10 to 20% capacity. Why? Well, because to prevent files from intermixing and to keep everything completely secure, we had to isolate applications. And the only way to guarantee 100% isolation on physical servers back then was to buy a separate physical machine for every single application. So we had these incredibly powerful muscle machines just sitting around, wasting 80% of their processing power. Which brings us to the game changer in Section 2. Enter the hypervisor. Okay, you really need to firmly grasp this concept. The hypervisor is literally the magic engine of modern IT. It's a software emulation layer that lets us slice up a single physical server into multiple virtually isolated pieces. We call these pieces virtual machines, or VMs. So instead of bringing a literal physical saw to a server to cut it into smaller servers, the hypervisor provides a hardware abstraction layer that does it entirely through software. Let's look at how this builds layer by layer. At the very foundation, we still have our physical bare metal hardware. But instead of a traditional operating system, we install the hypervisor right on top of it. This abstraction layer is what changes everything. Because of it, we can create multiple independent virtual machines on that single physical box. And even better, it allows us to run entirely different operating systems right next to each other. You could have a Linux server, a Windows server, and a Mac server perfectly isolated, all running simultaneously on the exact same physical piece of hardware. It totally simplifies our multi-operating system environments. If you're a visual learner, think of a physical server's hardware resources, like its CPU, its RAM, its hard disk storage, like a massive pie. The hypervisor essentially acts as the knife. It distributes perfect, virtual instances of memory and processing power to each virtual machine, without anyone's skiles ever intermixing. So, one slice gets 2 virtual CPUs and some memory. Another slice gets a completely different allocation. Everyone gets their piece, and nobody touches the others. Moving right along to Section 3, the 3 pillars of virtualization. You're going to want to keep this definitive mental checklist handy. These 3 main benefits are the exact reasons our operational efficiency just skyrocketed when businesses mandated virtualization over traditional physical infrastructure. Number 1, better hardware utilization, which leads directly to massive cost reduction. Number 2, unprecedented agility and much faster scaling. And number 3, simplified disaster recovery and backups. Let's break these down one by one, starting with utilization. Take a look at this. It brilliantly illustrates the cost reduction strategy. Through a process called server consolidation, we take multiple applications that used to require their own dedicated physical servers, and we isolate them all on a single, powerful physical host using virtual machines. Suddenly, we're boosting our hardware utilization up to 90%. We aren't buying 5 different servers running at 20% capacity anymore. We're buying one server, running it at near maximum capacity, and saving an absolute fortune in hardware, power, and physical real estate. Let's dive deeper into Section 4, agility and faster scaling. The difference here is just night and day. If you need a duplicate environment to safely test a new application today, you don't have to wait weeks for hardware to be shipped and installed. Virtualization reduces the time needed to deploy new testing environments from months down to mere seconds. You literally just log into a management console, specify the CPU and memory you want, and hit launch. Scaling up a popular application no longer requires dealing with hardware installation bottlenecks. It just takes a few clicks to provision new virtual resources. This is exactly how modern IT teams scale resources exponentially faster than using physical hardware. But hey, speed and cost aren't everything. As you grow in this field, you'll learn that reliability is just as critical. I still have nightmares about the physical server that failed at 3 a.m. You honestly don't know the sheer panic of a physical motherboard frying in the middle of the night, taking all your critical applications and data down with it. With bare metal, your backups are heavily hardware dependent. Trying to restore a failed physical server onto a slightly different piece of hardware was an absolute nightmare. Which brings us perfectly to our final pillar, Section 5, Simplified Disaster Recovery. Moving to virtual environments simplifies system backups entirely. Because a virtual machine is essentially just a set of software files sitting on a hypervisor, we don't have to worry about hardware dependencies anymore. We just take a snapshot, a complete point-in-time copy of your entire VM. If disaster strikes and the underlying physical server catches fire, we don't panic. We simply grab that snapshot file and effortlessly restore it onto any other compatible hypervisor in the data center. The application spins back up exactly as it was. It's an incredible contrast, bare metal server deployment times versus the sheer agility of instant virtual machine snapshots. So let's recap our session. The hypervisor abstracted the hardware, allowing us to consolidate servers, slash cost, deploy in seconds, and secure our systems with effortless backups. Understanding this foundation gives you incredible power as an IT architect. You are no longer bound by shipping delays and heavy metal boxes. You now have the agility of an entire virtualized data center right at your fingertips, which leaves you with one vital question to answer as you continue to build out our modern infrastructure. What are you going to build next?